We can continue, students. Good morning. We can start. So last class, few diagrams. Okay, we study mainly few diagrams. So each and every diagrams are important. Okay. So they will ask to complete the diagram like that possible. So today we need to complete few more diagrams. Okay. Few more diagrams remaining in the same section only. We have few more diagrams. So we can start. Okay. Okay. So next one, we are taking another kind of prism. Okay. One more type prism. Okay. Today, this Friday. Okay, means it's coming Friday. You have a small test paper only. See, in this test paper, you have only diagrams from chapter 4. Okay, this Friday, you have a small test paper. The special test paper is that. Okay, that I will ask. Don't worry about how I ask. That I will find the method. Don't worry about it. In this chapter 4, this Friday, test paper, only diagrams. Okay, no theory or nothing else. Only diagrams. This Friday, you have test paper. It's coming Friday. Okay, I think 2 or 4 days are there. The time I will inform on group. Okay, time I will inform on group. I will confirm date also. I will confirm. Most probably this Friday, maybe 6 p.m. or 7 p.m. There will be a test paper. Okay, students, wait 1 minute. There will be a test paper only with the all section. All sections are there, including all the section. This symbol chapter 4 only. Okay. All the section, all the diagrams from chapter 4. Okay, this Friday, test paper, chapter 4, only diagrams. All the section, diagrams in all the sections will cover. Okay, the diagrams which I told you to study. Okay, so we can continue. Few more, okay, 3 or 4 more diagrams are there, so we can continue. 4 more diagrams are there. Next one, we are using the right-angled prism. Previously, we used one rectangular prism, but other 2 angles are 45. Here, in this case, it's a prism only. One angle is, as usual, 90, and one angle is 30, and other angle is 60. A prism like this. Okay, right-angled prism. One angle is 60 and another angle 30, like that. Okay, so we can start as usual. We can give name A, B, C. Light ray reach the prism through BC. Through BC means you have to understand that the side opposite to 30 degree, like that you have to understand. Okay, when light ray incident through BC means you have to not about name, you should know the light ray incident through the side which is opposite to 30 degree. Like that you have to know. Okay, otherwise with the name you can't able to distinguish which side it is. The side opposite to 30 degree angle. Okay, incident. So as usual 0 degree. What happened? No deviation. And reach here. Okay, I am repeating again, listen here. Okay, I am repeating again, we are starting prism. What is type of prism? Rectangular prism, but angles are different. Okay, 30 degree, 90, 60. Okay, ABC, and later enter through the side opposite is 30 degree. Light ray entered through the side which is opposite to 30 degree. Like the light ray entered. What happened? They reach here. Okay, because 0 angle, no deviation. 0 angle of incidence, no deviation. Then now you can guess this angle is 2 parallel lines. So this angle is 30 This angle also 30. Okay, how you get it? This angle, not worry about it. Okay, then what happens? If it is normal, total 90, till here 30, what's remain? 60. So what's the angle of incidence? 60 degree. If a light ray enter with an angle 60 degree, normally in the case of glass, 30 you see critical angle. So if 16 is the angle of incidence, light ray will undergo total internal reflection. Reached here. Okay. Then here the angle of incidence will be, okay, we can calculate, say 30. Here the angle of incidence will be 30 degree. Angle of incidence will be 30 degree, like that. See, just imagine a straight line here. That angle is 30, then opposite angle 30, like that. Okay, don't worry how you get it. So the angle of incidence is not above the critical angle, below the critical angle. So what happened? Later undergo refraction. Refraction means denser to rarer, bent away from the normal. Bent away from the normal. Okay, so let's see what are the phenomena is happening. Okay, just go through this diagram. So from beginning, we see this side opposite BC. Through BC means you have to understand that side opposite to 30 degree angle. Side opposite to 30 degree angle. Later incident with an angle 0. 0 angle. Means no deviation reached here. Here the angle of incidence is 60 degree. What happened? Greater than critical angle. Later undergo total internal reflection. Reached here. Again what happened? Later reached here. Again what happened? Denser to rarer. Later bent away from the normal. Okay, denser to rarer medium. The later bent away from the normal. So it's a diagram. Any clarification you can clear it now. If you have any clarification, you can clear. Any doubts? Anybody? Anybody have any doubts? Okay, any doubt clarification? Any clarification is clear now. Okay. Okay. Okay, listen, I'm repeating again. Just listen. The light ray enter through a site which is opposite to 30 degree angle. First of all, I understand that. First condition, light ray enter through a side which is opposite to 30 degree. Okay, what happened? Opposite to 30 degree as 0 degree, through 0 degree. The sine opposite to 30 degree angle through an angle 0 degree. So 0 degree always, whatever may be the medium, doesn't matter, 0 degree, no deviation, and reach here with an angle 60 degree. So if the angle of incidence is 60 degree, what happened? It will undergo total internal reflection and reach here. Okay, from here later undergo total internal reflection and reach here. Here angle of incidence is 30 degree only, so it's less than critical angle. So what happened? Just refraction. Denser to rarer, later will bend away from the normal. Okay, anybody? Any more clarification? Anybody have any doubts? Any doubts? Else we are going to start on next diagram. Okay, so we can continue. Okay, we can continue. So next diagram, we are continue through next diagram. Okay. Next diagram, just understand difference between these two. 30 degree, 60 degree, 90 degree. See, this time the angle of incidence is through the side opposite to 60 degree angle. Okay, see, study according to the angle. Here the side opposite to 30 degree, here through the side opposite to 30 degree with 0 angle. What happened as usual? 0 angle, no deviation, and reach here. Okay, here is the normal. You can guess what will be the angle of incidence. It's almost around 30 degree only. So it means it's less than critical angle. What happened? Later undergo refraction, bent away from the normal. Okay. So easy diagram. You see here, first angle of incidence is 0. Here, no deviation. Reach here. Angle of incidence is 30 degree. 32 is almost the critical angle for glass. So it's less than the critical angle. So now the total refraction, just refraction. Denser to rarer, later bent away from the normal. That's it. Okay. So as we started through an angle opposite to 30 degree. Next one opposite to 60 degree. What will be next one? Through a side opposite to 90 degree. Okay. Next diagram. Okay. Okay, through a side opposite to 90 degree. Okay, through a side opposite to 90 degree. So let's reach here again. Okay, 60, 30, 60, 90. So this time opposite to 90 degree angle. What happened? Denser to rarer to denser, but angle is 0, so no deviation. It reach here. Okay, here. Okay, not parallel to base like this. Bending is bending, not parallel, but not parallel to base. Okay, reached here. Again, what happened? Denser to rarer. Angle of incidence is around 30 only. Denser to rarer. Okay, it's angle. The angle of incidence is around 30 only. Denser to rarer. Later bent. Okay, this angle 30 degree. Denser to rarer. Bent away from the normal. Not that much bending. Okay, anyway, denser to rarer. Later bent. Okay, doing this again. Okay, start from beginning. Prism 30, 60 degree, 90. Later enter through normal, means 0 angle. Denser to, no, 0 angle, no deviation, reach here. Okay. Okay, no deviation, reach here. Okay. Then here it is angle of incidence is 30 degree. So what happened? Denser to rarer, later bent away from the normal. That's all. Okay. Since third one have one more special diagram will be there, but just to go through this 3 diagram. If you have any clarification, clear it now. If you need any clarification, clear it now. Else we have to go through next diagram. Okay, just to go through each and every diagram. Alan, just talk. Alan. Alan, just talk. Alan? 4 point, no. Which one? Yeah, I can't able to hear properly. Alan, just talk. Alan?
Understand the 4-point beginning. Please explain it once more.
Where is issue? Which one? 4 point? Okay, see second diagram. Okay, see, in this diagram, see till here it's a straight line, no deviation because the angle of incidence is 0. Reach here, then center error, went away from the normal. That's all. Here also same thing. 0 degree angle of incidence, no deviation, then center error, went away from the normal. Just two refractions only. Why total line reflection doesn't occur? Simple thing. Here, the angle of incidence is less than critical angle. 30 degree. Both the case, the angle of incidence is 30 degree. So, no total line reflection occur. Okay. Here, no need. I think there's nothing to think about it. Just which side. Just you have to know which side is entering. Okay. Then here, no deviation. So, straight reach here. Then center error, bend away. Okay, angle of incidence, calculating angle of incidence. Okay, actually 32 is the angle of incidence. Each case different methods are using. Okay, to study all this method is not easy. See, this case I already told you the angle of incidence, how to calculate. See, total angle. See, if you consider this one, the total angle will be, okay, this angle is, okay, just to consider this two. Okay, this, okay. This angle is 60, this one also 60 because these two lines are parallel. So this angle is 60, this angle also 60. Then total 90, so remaining 30. Okay, not easy to calculate. Okay, so see these two lines are parallel. So this angle is 60, this angle also 60. Total 90. Around a normal total angle always 90. So remaining angle is 30. Like that we calculate. Don't worry about this how to calculate because not easy. See. Here you can imagine two triangles. Here one triangle is here, this triangle is here. Okay, in both triangle one angle is 90. Okay, see this angle is 60 also here. This angle is 60, here also 60. So remaining angle is 30. Like that we calculate. Each case we use different methods. There are no common methods. So it's better to study. See here we consider two triangles here. Okay, if this angle is 60, this angle also 60. This angle is 90. So what is remaining angle? 30. Okay, like that we calculate each case. Different methods. There are no general methods are available. From the diagram, okay, I am not suggesting to study the method to calculate. It's better study the diagram. Okay. No, you can't calculate each and every diagram. Okay, methods are there. Calculating is exactly based on maybe some triangle property or angle properties we are calculating. Methods are there, but I think it's wastage of time to know the method other than studying this diagram. Okay, one more diagram remains. Okay, a third one only, but in another way. See, if the light ray incident normally, okay, listen. Third one only, I am repeating that again, but in another way. See the third one. Just imagine the light ray reaches the base. Okay. See, previous one doesn't touch the base, but here if the light ray touch the base, what happen? Angle of incidence will be greater than critical angle. Okay. So this angle is 30, 90, 60. Okay, how to know the angle of incidence? See, this angle is 60, this angle is 90. So this angle is 30 and here it is 60. So the angle of incidence is greater than critical angle. 60 degrees angle of incidence. It's greater than the critical angle. So what happened? Let it undergo total internal reflection and reach here. Again, let it undergo refraction. Later reach here. Okay, so according to the diagram you have to complete. Last, this one and that one, the side is same. Both case, let it enter to the opposite side to the 90 degree angle. Both case, let it enter to through the opposite side to the 90 degree angle. but here the light ray inside the prism doesn't touch the base, but here light ray inside the prism touch the base. That's the difference between these two. Here doesn't touch the base, but here light ray touch the base. So what happened? The angle of incidence is 60 degree. Light ray undergo total reflection. Okay, here the angle of incidence is 30 only, because this angle is 90. So this is 60. See, if this angle is 60, this angle also 60. This angle is 90. So remaining angle will be 30. So at 30 degree angle does not undergo total internal reflection. Okay, I am saying this again. I am not stressing on the method. Just to draw, study the diagram. Okay, because each diagram different methods you are using. So it's better than you studying the diagrams in each method. You have to study the diagram. It's easier, I feel. Okay. So see, actually everything you can calculate. Every angle you can calculate. Here everything you can calculate just by using trigonometry and properties of angle and triangle properties. You can calculate each and every angle. Okay, but each diagram different methods are using. Okay, I can say that a method, but I can suggest you to study through that method, because it's better to study the diagram. Okay, different methods. See, what's the method used here? It's different from here. So different here. It's different here. Each and every diagram different method we use to calculate the angle of incidence. So I think I am suggesting it's better to study the diagram. Okay, if you want to know, I will already explain how to obtain the angles. Okay, so 4 diagrams from this section. Okay, 4 diagram using simple same prism only. Same prism only, 60 degree, 30 degree, 90 degree. Same prism is used. But this 3 diagram, side is different. Letter ended through a side. That side is different. Then here letter doesn't touch the base inside the prism. Here letter touch the base inside the prism. Okay. So any doubt you can clarify. Okay, students, is it clear for you? Sound, is it clear? Yeah. Okay, listen. Okay. So see students, when you go through the diagrams, you may feel it's easy, but thing is that you feel it's confusing when you ask in exam. So no other way, you have to separately study each and every diagrams, prism related diagrams, not only from the section, previous chapter also one prism section was there. So separately you have to study each and every diagram. Okay, is it here for audible for you? Rosemary, is it sound is clear? Rosemary, I think the sound is clear here. Okay, yes, what about this? Is the sound is clear? Okay, Rosemary, sound is clear for others. Okay, Rosemary, for others sound is clear. Check there. If you are, okay, Rosemary, I think we already put in. Okay. So shall we continue? So these are diagrams in this section. Okay, these are the diagrams given in this section. Okay, next some uses of total internal reflection. Okay, there are some total reflection prism in place of plane mirror. See, compared to reflection, okay, compared to normal reflection, normal reflection you will study in our classes. Compared to normal reflection, always the total internal reflection is better. Why it's better? Already I mentioned that change in energy loss. Normal reflection, amount of energy will be absorbed by the surface itself. But here it is total internal reflection. So there is no loss. Okay, see we can compare these two. So 100%, that's the main advantage. 100% of the light get reflected. The case of total internal reflection, 100% of the light get reflected. but it not in the case of normal reflection. We can't expect 100% of the light being reflected in the case of normal reflection, but in the total reflection only 100% of the light gets reflected. Okay. Then if we compare these two, total reflection and reflection from a plane mirror. So total reflection, entire light get reflected, but plane mirror, a part of the light is reflected, and few portion is refracted and absorbed. Few portion will absorbed by the mirror itself. Okay. Then total reflection, there is a condition is there. Later I must travel from denser to rarer. But the case of normal reflection, okay, two conditions are there. Later I must travel denser to rarer. The angle of incidence will be greater than the critical angle. But in the case of normal reflection, the only condition is that the surface must be a opaque one. That's the only condition. Then energy loss. Okay, then which one should be the brighter image? As you know, you can think that the total reflection 100% light is being reflected, so it give you more brighter image than normal reflection. Total internal reflection will give more brighter image than reflection. Total internal reflection will give more brighter image than reflection. So these are the energy loss, like that. That's are the difference between normal reflection and total internal reflection. Okay. Then we can see this some consequence. Okay. You can see that mirage. Okay, mirage in desert. Mirage. Okay, I don't know if you don't know what's a mirage means. You may see that in some cartoons and all. In desert, if you go to desert, somewhere if you see that there is water, but when you go there, there is nothing. Okay, say we feel water is there. Okay, but actually it's not there. But you can see that in the case of hot sunny days, in wet road, hot sunny days, in wet road or pool of water, we can see in hot sunny days water is there in the road, like that you may feel. Okay, but actually nothing is there. It's seeing due to total internal reflection. Okay, say exactly how it's happening means I need almost 10 to 15 minutes to explain how we see mirage and how we see water in road on hot sunny days and all. You can study. You should study your science group. Any syllabus, if you continue studies in science group, +2, you can study exactly how this mirage is forming. Just understand formation of mirage and driver or sea pool of water or road is being wet. Okay, so seeing is due to the total internal reflection. Okay, then another example, just to place an empty test tube placed in water in a beaker. Okay, a beaker containing water, we just place an empty test tube. Okay, then if you observe from outside, we can see that the glass is being shined. Okay, not everywhere. When you observe through a certain angle, you can't able to see in each and every angle. When you observe this test tube through a certain angle, you can see that the glass is being shined. Okay, you can guess to the total internal reflection. Then, if there are any scratches in the glass, you can see that if there are any scratches in the glass, you can see that they are shining. That also due to the total internal reflection. Then diamond, the glow of diamond is also due to the total internal reflection. Then you may say that you may hear about this thing called optical fiber. optical fiber. Okay, I think, yeah, it's a black colored wire. You may see that dick in the sides of the road. Okay, it's optical fiber. Okay, through optical fiber, we can send light signal by using the phenomenon of total internal reflection. Okay, I know each these 5 examples need more 2 or 3 class explanation. That means big topics are there. Okay, in the textbook just to mention, so that's why I'm just mentioning only. How's happening means I need time to explain. Okay, otherwise you can able to think. Just imagine cracks in the glass. Okay, cracks means glass thickness is less. So I iterate from glass to air, denser to rarer. It's possibility for total internal reflection. So that make that shiny like that everywhere. Okay, this due to this phenomenon of total reflection. Okay, so I'm not mentioning how it's happening. These are things happening. Okay, in your textbook, 10th level, they only mean that these things all happening due to the phenomenon of or due to the effect of total internal reflection. Okay, mirage or road being wet in hot days, empty test tube placed in a beaker shines when you observe in a certain angle, diamonds glow, cracks of the glass that also glow, shines. Then signal transmission of light signal through optical fiber. So everything is occurring due to the phenomenon of total internal reflection. Okay, so this is all about this chapter 4. Okay, okay, it's all about chapter 4. Any doubts? Anybody you can clarify now? Anybody have any doubts? You can clarify. Wait. Yeah, all the diagrams are needed. All the diagrams are needed. There is a blue box. Just the page number for blue box. Yeah, I think 98 blue box. Yes, needed. Difference between normal reflection and normal reflection. That blue box is needed. Yeah, full lesson. Full lesson. This paper on this Friday. Full lesson. Not about one section. Full diagrams on that section. Okay, all the diagrams. Only diagrams only. So you can understand. Looking at this paper only for diagrams. How much important the diagrams are. How much important the diagrams are. You can understand from that. Okay. So, yeah. Anybody else? Anybody? Sound is an issue. Wait. Okay, wait. Okay. Okay, hope it's clear now. How sound? Yeah, okay. Fine. Okay, anyone else? Anybody? If you have any doubt, you can clarify now. If you have any doubts, you can clarify now. Anybody have any doubts? Okay, page number 99. Yeah, I just read it. Page number 99. Okay, just. Yeah, all the diagrams, even from examples also. Yeah, just to go through all the diagrams. Even from examples also, just to go through each and every diagram. In 100, one diagram is here. Yeah, all the diagrams. Even from examples, okay, all the diagrams you need to know how to complete it. Okay, see unsolved one, okay, all this one, okay, unsolved one, just leave over this unsolved one. If you can try. Okay, all the solved examples, everything is needed, all the diagrams are needed. Unsolved one, just try. Okay, else we can discuss in the class. Okay, unsolved one, okay, just to forget about unsolved one. all the solved one you have to know. All the solved diagrams you have to know. Just try unsolved one also you can try, because there are no numerical in this section. So just try the unsolved one. If you feel difficult, we can discuss in the class about this unsolved one. But other than that, everything you should know. Every diagrams, even the solved diagrams, everything you have to know. Page numbers 100, 99, each and every diagram they are asking. Okay, we can't say they will ask only from the syllabus portion only, means only from the theory portion only. From the exercise portion also they have asked. Previous question papers questions are there, so we can skip any of them. Okay. Okay. Any doubts? Page number 94. Okay, oh, that's part of syllabus, okay. That I forgot about the topic. Okay, I will explain. Okay, see factors affecting critical angle. Yeah, that also needed. That needed. I will explain. Factors affecting the critical angle. That I will explain now. Okay, just wait. What are the factors affecting? Two factors are there. Factors affecting critical angle. Two factors are there. First one, wavelength. Okay, see, glass, we say that 32 is not exact the number. Okay, it will vary according to type of the glass, temperature, like that. There are some external factors are there which depend on it. 4.60. Wait. Okay, wait. Okay, I will explain. Okay, 4.60. 4.60. See, that is okay. See that 4.60. That diagram, here that critical angle is, I think, critical angle is 60 degree. Then only it will happen. Okay, just try to read the question. Wait. Okay, see in the question is given that critical angle is 60 degree. Page number 99, question itself say that critical angle is 60 degree. If the angle of incident is 60 degree, from that you can calculate the angle of, see, the half of the, see, just imagine a normal. Okay, see, one angle is 60 and other angle is 30. So, idea is that critical angle is 60 degree, then what happened? It is the light ray will move through the surface. Okay, make an angle 90 degree. From the question itself is clear. Figure, I mean, page number 100, the diagram. How you obtain as? Then the question is they say that critical angle is 60 degree. So when a light ray incident within a critical angle, what happened? Light ray will emerge out. Light ray will emerge out with an angle 90 degree from the normal. Okay, so that's a critical angle diagram. Okay, I will explain that factors affecting the critical angle. Okay, two factors only. First one, color or wavelength. Okay, so as you know, when the wavelength increases, refractive index decreases. So from that you can clear that critical angle increases with increase in the wavelength. First factor, critical angle increases with increase in the wavelength. Next one is the temperature. Same thing. When temperature increases, critical angle also increases. Two factors depending on the critical angle. First factor is the wavelength or color. Wavelength increases, critical angle increases. Second one, temperature. When temperature increases, critical angle also gets increases. Okay. I just missed 2 points, that's all. Any more? Okay, wait, I will bring the rest of the course. Any more clarification, anybody? Okay, anybody have any more doubts? Okay, just to read each and every portion. Wavelength means wavelength or color. So we know the relation between these two. Color is dependent on wavelength. Color is dependent on wavelength. Critical angle increases with increase in the wavelength. Hence, color is dependent on wavelength. Critical angle increases with increase in the wavelength. Okay, and next one is temperature. Same thing. When temperature increases, critical angle increases. Yeah, that also mentioning there. Okay, see. Okay, see, the refractive index increases. Okay, wait. Okay, it's not there, but just understand that, other than the syllabus I am saying, when refractive index increases, refractive index of the medium increases, normally critical angle decreases. Alan, it's not there, but I am saying this thing. When critical angle increases, refractive index of the medium increases, critical angle decreases. No need to study. Renew, no need to study. Just understand glass of 32. Renew, no need to study each and every critical angle. Just understand glass have 32, that's enough. Nothing else needed. Renew, I think renew is last time. Yeah, anyone else? Okay, so this Friday, most probably 6 p.m. Okay, we have a test paper only with the diagrams in the section. In this another section, in this chapter 4, only based on diagrams. Okay, anyway, I will ask in different ways, so anything you have to know, study properly. If you don't have any doubts, you can go offline. Okay, see you next class. Next class we will start chapter 5. Okay, if you have any doubts, you can ask, else you can go offline. See you next class. Thank you.